All right, guys, we are going to be interpreting graphs of functions today. We're going to be looking at graphs, looking at certain things that are happening, and learning new words to describe what is happening. So we're going to talk about the intercepts, symmetry of graphs of functions. We're going to learn about positive and negative, increasing and decreasing behavior, extreme end behavior of graphs of functions. So lots of new terms. Um, please go ahead, make a list. So you remember that these are all the things that I may need to make sure I have in my notes today. Intercept, x-intercept, y-intercept, line of symmetry. Make this whole list, and then we will move on and identify what each of these things are later in this presentation. All right. Um, Interpret intercepts and symmetry. Okay, so you can interpret the graph of a function. You can estimate and interpret we can look at some key features. We can look at the intercepts of a graph. So say we have a graph that looks like this. We can look at where it intercepts the y-axis. So this would be the y-intercept, right? And where it intercepts the x-axis, which this would be called the x-intercept. You know, it could be that it looks like a straight line, and we would have this intercept and this intercept. Or it could be, you know, something that looks like this, and it has two x-intercepts and one y-intercept. So those are all the kinds of things we're going to be looking at in terms of intercepts. So make a note in your definitions. Y-intercept is where it intercepts the y-axis, and the x-intercept is where it intercepts the x-axis. Here we have a graph of something that's been launched at a certain point and goes up in the air and then falls down. And that happens over time. So the function is time, right? The height is affected by the time. So let's look at this. Let's identify this. Is this a linear or nonlinear function? It is a linear or nonlinear function. It is a nonlinear function, correct? Then let's estimate and interpret the intercepts. What intercepts do we see? So you notice the y-intercept is at about 0, 15, right? And the x-intercept is a little after 7. So could we say maybe 7.5? Or so this is at about 7.5, comma 0, comma 0. So there is the y-intercept and the x-intercept. Y-intercept, right? And the x-intercept. And what does that tell you? What do you know by looking at those two intercepts? You can presume that something was launched at about 15 feet, shot up into the air, and fell to the ground. All right? You might have been on a cliff and shot a rocket up into the air and it fell down. You weren't on the ground, you were up 15 feet. Or you might have been on a rooftop. Okay, here's one for you to look at. This is your guided practice number 1. The graph shows the temperature y of a medical sample thawed at a controlled rate. Identify the function, is it linear or nonlinear, and then estimate and interpret the intercepts. Estimate where they are, 1. So 1, you want to estimate where they are. And 2, you want to interpret what they mean. What does that mean? What does that mean? What do you think it means about where those two intercepts are? Okay? The graphs of some functions will show you other key features. Another one that it shows you is symmetry. Everybody remembers what symmetry is? So if a graph poses a line of symmetry, it will pose a line of symmetry on the y-axis or on some other vertical line. Here we have symmetry, and what it means is that so this line is the same on this half as it is on this half, right? They're symmetrical across this axis. In this case, it's a vertical line at, at what? Ooh, 3 point, it's at the ordered pair, I would say about 3, 3, comma 0. It's not at 3.5. It's close to 3.5 though, and it's not to 4. All right. So, and make a note that the graphs of most real-world functions, real-world things, do not exhibit symmetry. Symmetry is pretty rare in that kind of graph. However, you may see smaller portions of the domain that are worth looking at. So just keep that in mind, that symmetry might occur for a little while and then it changes. So here we have an object launched. The graph shows the height of the objects as a function of time, right? Describe and interpret any symmetry. Well, what do we notice about this? The right half of the graph is a mirror image, right, of the other half. And the line of symmetry is where this is called the line of symmetry. And it occurs at what point? X equals 3.5. Well, they said 3.5. I said 3.3 before. Okay, so that's where the line of symmetry is. X is always 3.5. That's that whole line going up there. And now, can you interpret that line of symmetry? What do you think it means? To me, this means something took off from the ground and it went up and it fell back down at the same pace as it went up. All right, so it went up and down at the same rate. Here's one for you. Your guided practice here is to look at the graph in practice 1 and describe and interpret that, any line of symmetry if there is one. Okay. The second thing that we're going to talk about, so we just finished talking about intercepts and symmetry. Now we're going to talk about extrema and end behavior and interpreting that on a graph. So you can, oh, I wish I had a highlighter. Where is it? I don't know. Okay. So when you interpret a graph, it involves, like we said, estimating and interpreting where the function, we want to look at where the function is increasing, where it's decreasing, where it's positive, where it's negative, where it has extreme values, and of either high or low. So we're going to be looking, when we're interpreting functions, graphs of functions, we're going to look at how it increases, an increase in behavior in the line, and a decreasing. And we're going to look at positive and negative value, extreme positive or extreme negative, or just general positive and negative, what's happening, right, if it's going up or down. And then we're going to look at the extreme, high, and low. Okay, we're going to look at each of these individually here in the next few slides. All right. A function is positive where its graph lies above the x-axis. So if you look at this part right here of that graph, it lies above the x-axis, and right here lies above the x-axis too. So that is where it is positive. It's negative when it lies below the x-axis. So right here is negative, and right here is negative. Okay? So that's the positive and negative that you're going to be looking at and interpreting. You can also look at a graph and see if it's changing. Is it increasing? Is it decreasing? And if we look at this example, we can see that it's decreasing here, right? And then it changes and it starts increasing and then it's decreasing again. Pretty self-explanatory, right? Okay, the points shown are the locations of relatively high or relatively low function values, and these are called extrema. Point A right here, is the relative minimum, right? And point B is the relative maximum. Again, it's the point that there's nobody that has a lesser y coordinate, is the way they put it. And point B, there is no other place nearby that has a greater y coordinate. So maximum goes with the highest number, greatest y coordinate. The relative minimum goes with the lesser y coordinates. Again, pretty self-explanatory. If I were taking notes, I would draw these pictures on each of these graphs and label these points. So you have a picture for the term. If you need to go back and do that if you didn't do it on the other two graphs. Finally, we have end behavior. End behavior describes the values of a function at the positive extremes in each domain, okay? Excuse me, in its domain. So as you move from left to right, we can see that the graph goes up. As x decreases, y increases. As we move to the left, right, what's happening at this end behavior? This is decreasing, right? The y value, let's stop this just a second, guys. Hold on here a second. Okay, let me say this again about end behavior. It describes how the line's going to move, right? When I look at this line and I notice as I move towards the left, stop. When I move to the left, it the graph is going to go, the y value is going to go up, right? The x value is going down as we move across this line, and the y value is going up. So as x decreases, right, the x is decreasing, the y is increasing. And as you move to the right on this graph, you'll notice that as the x goes up higher, right, the y decreases over time. Okay? So that is just explaining how in general the line is moving. All right, let's look at a video games problem for ourselves. Okay, let's read through this. U.S. retail sales of video games from 2000 to 2009 could be modeled by the function graphed at the right, but in this case, it's at the bottom. Estimate and interpret where the function is positive and negative, right? Where it's increasing and decreasing, where the x-coordinates of any relative extrema, and the end behavior. So we have several things we need to do as we interpret this graph. So let's look at positive and negative first. The positive is between about negative, x is negative 0.6, right? Positive 0, the x equals negative 0.6 right here. And the x is also at 10.4. The negative is less than 0.6. It's everything down here, and it's x is greater than 10.4. So when x is greater than 10.4, this is going to be negative, and when x is less than 0.6, it's going to be negative. And everything that's positive is between here and here. What does this mean? This means that there were positive sales between about 2000 and 2010, right? So from about the beginning until here, they had generally positive sales. But according to this graph, after 2010, it looks like the whole industry was going to collapse. But in fact, it might be that we can't really use this graph after 2010. It might only have information from between those dates, and that's why it records like that. Okay, increasing and decreasing. Let's look and see on this graph, when is it increasing, when is it decreasing? All right, it's increasing when x is less than 1.5, right? So here is 1.5, right, on our x. Oh, I wish the guy would go away. Thank you. How can I make him just disappear? Well, let's try it again. So at 1.5, right about here, and going this way, x, the graph is increasing, correct? All of this is going up, so it's increasing there from this value down. And what's going to happen? And then it is also increasing from 3 up to 8. So all of this part is increasing. Where the x is 3 or the x is 8, that place, it's also increasing. It's decreasing between here and here, right? Between 2 and 3 approximately. When x is 2 and x is 3, it's decreasing. And then it decreases again after 8. So what does this mean? What does that tell you? What do those relative maximum and minimums and the increasing and the decreasing tell you? It tells you that sales increased from 2000 to 2002. It decreased from 2002 to 2003. And then it increased again from 2003 to 2008. And as it has been decreasing ever since 2008. We saw these on the last picture, the relative maximums and the relative minimums. The maximum is x equals 1.5, right? We have two maximums. We have one here, and we have one here. We have two relative maximums. One is at x equals 1.5, and the other one is at x equals 8, or 2008, right? And at 2001, halfway through the year is what that means. A relative minimum is at x equals 3 right here. So around 2003 was the worst sales they had. Yeah, so the extreme of the graph indicates that the industry experienced two relative peaks in sales during this period, one around 2002, like we said, and another around 2008. And how much was it? It was approximately $10.5 billion, and it was in 2008, it was almost $22 billion. Okay, thank you. All right, the end behavior. As x increases or decreases, the value of y decreases. That is the end behavior that we're seeing. As x increases or decreases, the value of y decreases. So what do we see happening? As you move left, the graph goes down, doesn't it? As you move to the left, the graph goes down. As you move to the right, the graph goes down for the end behavior. What does that tell us? That tells us that negative sales they had negative sales several years prior to 2000 and several years after 2009. But that's probably unlikely. So then you have to think that, well, maybe what it says is that this was only data that was recorded from 2000 to 2009 and can only be used to predict sales to 2010. All right. Hold on, I'm going to stop it again. Bear with me, guys. Sorry. Okay, so for your last guided practice, let me increase this. Your last guided practice, right? I didn't photograph this, so I'm going to write it by hand. Is you're going to look at your guided practice. Oh gosh, do not like the orientation. The guided practice number 1 that we did in that first graph, okay? And for that graph, you're going to find positive and negative and interpret. You're going to find increasing and decreasing and interpret. You're going to find the relative extrema. And finally, you're going to describe the end behavior. Is that everything? Make sure I got it all. Yeah. Okay. So you do these 4 things for that guided practice, that first graph that we've been using as our guided practice all the way through this lesson. Good luck with it, and we'll talk about this in class. Thanks.